Okay, hi again everyone. We are now on page 30 of our statistics class notes in section 3.1, looking about numerical summaries for symmetric distributions. Okay, so we talked about the mean or the average as measuring the center. Now we want to talk about how do I measure the spread. So recall the variability in a distribution can be measured by the horizontal spread. So why is this important? Well, we would like to know if most of the data is near the center, remember the typical value, that's what we think of the center as, the typical value, or is it far from it, right? Where is the data? Is it spread out really far from the center, or is it close to it or far from it? Okay. Example 32. These are a couple histograms. They record the daily high temperatures in degrees Fahrenheit over 1 year in Raleigh, North Carolina, and Houston, Texas. Again, this is real data. Some people might call this a little skewed left. Yeah, probably I would agree with that. This is more symmetric. Yeah, that's probably the right way, right? So how would you describe the shape of each graph? Raleigh is symmetric. Unimodal, really no outliers. Houston is left skewed. Unimodal, no outliers. Okay. Now, which graph appears to be more spread out? Which graph appears more spread out horizontally? So at first glance, I'm kind of looking here. It looks like Raleigh's temperatures go from, that's 30, so around 25-ish to 90-ish. And it looks like Houston's temperatures go from about 30 to 100-ish. I mean, but most of these down here, there's not a lot of days where it's these colder temperatures. Most of the temperatures are up in here, right? Skewed left. So most of the temperatures are in here, whereas Raleigh's kind of, it's unimodal and symmetric, but they're really spread out among the temperatures on the x-axis more. So Raleigh's graph, more spread across the different temperatures. Okay, so how do we measure the spread for symmetric distributions? We use something called the standard deviation, which is a number that measures how far away typically the observations, which we call x, are from the mean, x bar, in other words, the center. For most distributions, a majority of the data is within one standard deviation of the mean. We will have a tighter rule of thumb later, but just think that for most distributions, a majority of the data is within, where's my cursor? There it is. A majority of the data is within one standard deviation of the mean. So I want you to think of the standard deviation as the typical distance of the observations away from their mean.